Hello everyone, this is Siri from the department ECE section C. Today my topic is about interplanar spacing. What is interplanar spacing? Interplanar spacing, it is denoted as a D, is the perpendicular distance between two adjacent parallel planes of atom in a crystal lattice. It is a fundamental parameter that describes the internal geometry of a crystalline material. Importance of interplanar spacing. The spacing determines how the crystal interacts with electromagnetic waves, especially X-rays. It acts as the unique fingerprint of a material, allowing scientists to identify substances based on their atomic arrangement. Visualizing lattice planes. Crystallography planes are defined by Miller indices HKL. These indices represent the orientation of the plane relative to the crystal axis. Parallel to two axes cuts 1, parallel to one axis cuts 2, cuts all the three axes. The mathematical foundation. For cubic systems, the relationship between spacing and indices is elegant in its simplicity. For cubic crystals, DHKL is equals to A by H square plus K square plus L square. Variable definitions. DHKL interplanar spacing, A lattice constant, unit cell edge length HKL or the Miller indices. Calculated D spacing for 110 plane in a crystal with lattice constant A is equals to 4.0. First, we have to identify indices. H is equals to 1, K is equals to 1 and L is equals to 1. Square and sum. 1, 2 plus 1, 2 plus 0, 2 is equals to 2. And third, applying the formula D is equals to 4.0 into 2 is approximately equals to 2.83 angstrom units. Brock's law. Connecting waves to planes. Interplanar spacing is experimentally measured using X-ray diffraction. N lambda is equals to 2D sin theta. Constructive interference occurs when the path difference 2D sin theta is equals to an integer number of wavelengths in lambda. Inverse relationships. D versus theta. As the diffraction angle theta increases, the interplanar spacing T corresponding to the reflection decreases. High angle peaks correspond to closely packed planes. Determinants of spacing. Lattice constant. The physical size of the unit cell A, B, C. Larger unit cells generally allow for larger interplanar spacing. Crystal systems. Whether the crystal is cubic, tetragonal or hexagonal defines the complexity of the spacing formula. Indices HKL. Higher order indices, example 220 versus 100, represent planes that are closer together, resulting in smaller d. Scientific significance. Material identification. Every crystalline substance has a unique set of D spacings PDF card acting as a fingerprint. Strain analysis. Stress can stretch or compress atomic planes. A shift in D reveals internal strain. Purity verification. Presence of D spacings not belonging to the target material indicates impurities. Thermal expansion. Measuring D at different temperatures helps calculate thermal expansion coefficients. The architecture of the solid state is defined by the spacing of its planes. Thank you. Make a photo.